Hello everyone, welcome to my presentation on our paper, Discovering the Design Challenges of Autonomous Vehicles through Exploring Scenarios via an Immersive Design Workshop. I am Jaemyung from ID KAIST. The interest in AVs is growing day by day. At this point, it is important to explore what will happen when AVs come into our real life, especially what problems can arise. In particular, in the early days of introduction of AVs, more problems can arise in an environment where people, vehicles with drivers, and AVs are mixed. However, many studies so far have focused only on a few issues, such as decision-making and crossing the road. These issues are very important issues directly related to safety, but we saw they were not only issues. For these reasons, we aimed to explore scenarios that have a high possibility of causing problems in mixed traffic situations between AVs and human road users in the future. However, to achieve this goal, traditional research methods have critical limitations. Usually, researchers using these three methods for studying AVs. First, via simulation, second, ghost driver, and third, real-field test. In case of VI simulation, it is difficult to explore situations which is not predefined by researcher. In the case of the ghost driver method, it is still difficult to explore various situations as it is greatly influenced by the safety protocol. Although testing in a real-world environment helps to explore more direct problems than any other method, commercially available AVs are still limited, and it is known that it takes a lot of time to explore all problems in this way. To overcome these limitations, we proposed an immersive design workshop for exploring problem scenarios of AVs. Scenarios are not simply variations on the same theme. Rather, scenarios provoke creative thinking, challenge current views about the future, inform about the implications of uncertainty, widen the range of alternatives considered, and help overcome the availability bias. In the HCI field, scenarios are used to identify potential problems. These advantages of scenarios fit the needs of AV research, which is difficult to perform in real traffic situations. We consider two main points for our workshop. First, the tool should be able to create various situations. Second, the participants should be able to experience the situation through the tool. For this reason, we adopted tangible miniatures and two action cameras. Participants could set the situation through road ties, car models, and human models. Also, using the front displays and two action cameras, participants were able to explore the situation from a first perspective. The workshop consisted of a total of 4 stages. In the introduction session, which is the first step, basic AVs information was delivered to participants and the purpose of the workshop was communicated. In addition, since the workshop was conducted as a team of 3 people, an ice-breaking session was held to create an environment where the team members could easily discuss. During the main workshop session, participants were free to discover problem situations. In addition, photos of various road conditions were provided as a stimulus so that participants could explore problems from various HRU perspectives and focus more on finding problems. In the last interview session, interviews were conducted on the participants' overall experience and scenarios discovered. Through the workshop, we were able to get a total of 133 scenarios. Also, in the internal evaluation, all scenarios were evaluated as appropriate. For the analysis, two researchers conducted an independent analysis, and through the discussions, 51 main elements were discovered. And finally, we discovered 5 factors that compose the AVHRU problem scenario. The factors are scenery, actor, triggering action, cause of the problem, and expected result. The scenery refers to the surrounding components other than AVs and HRUs that participate in traffic situations. The actor refers to traffic participants who act with their own will in the traffic situation and their attributes. The triggering action refers to the maneuver of the actor that causes the problem. The cause of the problem refers to the actor's instinctive reasons or limitations that induced the problem. The expected result refers to the result anticipated with regard to a problem situation. Also, we are able to create diagrams for each factors. A diagram of the scenery is shown here as an example. It shows hierarchy of elements. Also, the circle's size in diagram is proportional to the number of scenarios in which the element is found. The cited literature after the element in the diagram was written to indicate how frequently the element was used in previous studies. You can find diagrams for different factors in our paper. We thought that the factors found through analysis could be used by designers in a typical user-centered design process. User-centered design process was usually defined as an iterative process with 4 phases. Designers can define use conditions by scenery and user by actor in understanding the usage context phase. Furthermore, it is important to consider the triggering action in the AVHRU problem scenario in this phase. Also, designers can use the cause of the problem factor as the basis of design requirements for AVs. Moreover, designers can decide their measurements on the basis of the expected result of the scenario they are targeting. This process will help designers create richer designs. We were also able to discover 7 design challenges through comparison with previous studies. 1. Educating a mental model through design. 2. Understanding social norms. 3. Aggressive AV driving behavior. 4. Psychological human barriers. 5. Solving the blind spot problem. 6. Communicating with humans who are not in the situations. 7. Privacy issues. A detailed description of each design challenges can be found in the paper. We believe that the 7 design challenges will give designers and researchers the direction of the future. Our immersive design workshop, which made this discovery possible, gave the 2 characteristics different strengths. Tangible miniatures helped participants to broaden their frame of thought. Moreover, participants were able to create situations beyond those provided by the researchers through combinations of various tangible materials. In addition, participants were able to evaluate the validity of the situation through the perspective camera and display. Also, they can share their thoughts with other team members and more immerse and focus on the situation itself through the perspective camera. In summary, our study has a total of 4 contributions. First, we propose HRU perspective-centered research method. Second, we defined 5 factors of problem scenarios between AVs and HRUs. Third, we also propose a way to utilize these factors in the usage process. Lastly, we derived 7 future design challenges. This is the end of the presentation. Thank you for the listening. If you have any questions about the research, you may refer to the paper, and it would be appreciated if you contact the authors by email at any time.